Hello everyone, here we are back at question 3 of week 2 practice. This time we're working the opposite direction and writing an equation of a trigonometric function instead of plotting a trigonometric function. So we'll work through this. I've realized that last video when we did this sort of problem, I was writing some of the answer down here. We'll account for that by adjusting where I write this. So getting right into this, the first decision we want to make is what function are we working with. This isn't tangent, it doesn't have all these vertical asymptotes, so it must be sine or cosine. So let's decide which one it is first, and we do that by looking at where this function begins. So at 0 radians, at 0 pi, where is this function? Well, this function, it looks like, is on the principal axis. And we can identify that because it clearly isn't a maximum if we keep following along. Clearly isn't a minimum, so it must be the principal axis because we haven't transformed this by what's called a phase shift at all. We won't do that to you yet. So this is our principal axis. So because it starts at a principal axis, we know we're working with a sine function. So this is y is some amplitude times sine of some b value determining a period times x plus some c value, which is determining what our vertical translation is. Yeah, I was going to say positive or negative there. So what we need to find is A, our amplitude. We need to find B, our value that determines what the period is, and we need to solve for C, which is our principal axis actually. Or in another term, it can be a vertical translation, shifting it up or down. So we've already found what our vertical translation is, or what our principal axis is, right here. 4 units up is what it keeps oscillating between. So our C value is 4. Now we can find our amplitude similarly by finding how far above or below this goes from the principal axis. So I'm counting by ones here. So here's one of the shifts. This is the vertical. Here's the vertical in the other direction. So rather than counting these, I just see it's going from 4 to 5. So this is 1, this is 1, so A is 1. Last thing we want to find here is what is our B value? What is shifting, or what's happening to our period? So we just follow this along and see how long it takes for it to go through one period. So if I clear all this out and just trace this till I go through one full revolution, I'm starting at the principal axis. I'm at a minimum. Back to the principal axis. We're halfway right now. I'm at a maximum, and back to the principal axis. This sequence of movements is happening over and over and over again. So pi halves is actually our period. So the last thing we need to find is what our period is. We want to solve for our period. Well, we want to solve for our b value. I misspoke there. We know our period. So we can use the equation period equals 2 pi over b, and considering pi halves is our period, it equals 2 pi over some b value. Well, we need to solve for b now. We can do this a few ways. First thing we can do is undo this divide by 2, or we can cross multiply this proportion by undoing the divide by 2 and the divide by b. So let's cross multiply. So we'd have b times pi is equal to 2 times 2 pi, 4 pi. Well, look at that. B is looking right at us. So B is equal to 4. So in the end, we have all of our values, A, B, and C. We just said B was 4 as well. So we can write this out. Y is equal to 1 times sine of 4x plus 4. And there's our equation written out. Hope this video helped. Look for the last question in a final video. I've decided just to break these into one video per problem so you can see exactly where they're at.